All right, this is section 16.1 and it's titled Integration by Parts. We've been doing some other things, but now we're going to do integration by parts. It's useful when the thing that you're supposed to be integrating has products of algebraic and transcendental functions. So transcendental might be the logarithmic, the e to the x, or the trig. That would be that. So we have either the logarithmic, the exponential, or the trig. And that's when you'll want to use this mostly. All right, so there is a formula for this, and you'll want to have that with you when you do your homework or when you're taking the test. The integral of u dv, assuming that you've divided it into parts, is equal to uv minus the integral of v du. Sounds confusing, sounds crazy, but it actually is not all that bad. The conditions for integration by parts. Okay, if the integrand can be written as a product of two factors, so the thing that's inside the integral, if you can break it apart into two things, then you could use that. If it's possible to integrate dv to get v and to differentiate u to get du. So you have to have things that will work with your formula, and you'll see that when we get started, and that the integral can be found. So those are the conditions. All right, let's look at an example, and there's two different methods to do this integration by parts. So we're going to look at the standard method first. All right, here's your problem, x e to the 5x dx. So we want to note right off the bat that we have two parts. We have that and we have that. So that's a product of two things. One of them is exponential. All right, so if we let u be the x, then what's left is the e to the 5x dx. And when you see the dx, that's going to be your part that you take the integral of. Okay, so on the u you take the derivative, that gives you du, and the integral of x is dx. For the dv, we've got to go the other way, so we're taking the integral to get v, and the integral of this is e to the 5x over 5. The dx goes away. So there's our four parts. We're going to simply plug them into our formula. All right, so here's u, here's v minus the integral of, we put v there, and du was dx. So we've got all that. Let's do a little work on that, and I think I wrote some things out here. So if you multiply these, you end up with x e to the 5x over 5 minus. Now let's talk about the integral of this. Over here I've written that. You could pull that 1/5 out because you've got a 1 up there and you've got a 5. So we'll pull the 1/5 through the integral sign, and you have 1/5 the integral of e to the 5x. E to the 5x, the integral of that is e to the 5x over 5. When you multiply those together, you get e to the 5x over 25. So that takes care of all of that. We multiplied that, and then we have a plus c because this is an indefinite integral. All right, so that's the regular standard method. Let's look at the tabular method. And if you saw the movie Stand and Deliver, about a teacher in California that they thought kids had cheated on the AP calculus test, this method was in that movie. Actually, it was one of the first times that we thought about using it. It is in your book. If you looked at the electronic book, it is in there. It's really easier in a lot of examples. All right, same problem. You make two columns, one called D and one called I. That's the derivative column, that's the integral column. So same idea. You have to have something you can take the derivative of, something you can take the integral of. You want to take the derivative till you get to 0. Okay? The integral you take, if you've already stopped here, well, you know you're stopping here. You draw diagonal line from this top one to the second one, second to the third, and that's all we can do. you start with a positive sign and you alternate signs down. This one, you don't have any more lines, so you've only got 2 signs. What it means is multiply this times this, that's done here, and that was positive, minus this times this, and you've already got your answer, which is the same thing that we got above. Okay, so it's a little bit easier actually. You don't have to worry about UV, you're just taking the derivative and taking the integral. All right, let's look at one other example. Standard method. We have the integral of ln(x) times 1 dx. The one's understood, but there's our 2 parts. All right, we don't have any rule for integrating ln(x), so that's going to always be the thing that we'll take the derivative of. That's going to be your clue. So if you see ln(x), it's going to be the u, and then we'll take the derivative of that. So we have u, and we have dx is our dv. You integrate 1 dx, and you get x. If you take the derivative of ln(x), it's 1 over x dx. So we fill in the formula with those pieces, and you can see that we get x ln(x) minus x plus c. All right, let's look at it in the tabular method. Again, you're going to choose ln(x) to go in your differentiate column, your derivative column, because we can't integrate it. So we've got ln(x), and if we took the derivative, we'd go to 1 over x. We keep taking the derivative, we will never go to 0. We will never get to 0. So we know to stop, and we draw a horizontal line. And I did this example so that you'd see, normally you want to try to go to 0. If you can't go to 0, you go ahead and stop, draw a horizontal line. Over here, we had 1 dx. When we integrate it, we become x. So we've got a plus, we've got a minus. This is ln(x) times x, that's here, minus the integral. When you have a horizontal line, it indicates that you have to do the integral again. So the integral of 1 over x times x, well, that's just 1. The integral of 1 is x. So you have x ln(x) minus x plus c. It's the same as we got up here. All right, as long as you have your notes to refer to, you should be fine on doing those. You have 5 questions on your homework. Let's look. They're right here on this sheet, so you can if you have that printed, you should have that and be looking at it. Let's look at how to work a few of these. The integral of 9x e to the 5x. So we've got our 2 parts. Here's 9x, here's e to the 5x dx. Take the derivative of that, you get 9 dx. Integrate this, you get e to the 5x over 5. You're plugging in, I've done a few of these with the standard method, a few with the tabular, but you have the notes that you could do either one. So we're filling in uv minus the integral of v du. Take all your parts, plug them in, do your integral, do your work. You should come out with 9/5 x e to the 5x minus 9/25 e to the 5x plus c. This is the way MathLab is going to want you to put that answer in. If you were doing it for me in class, you could probably leave it like this. They want the fractions separated out. So I'm just giving you a heads up that this is how MathLab's going to want the answer for your homework. All right. So on this one, this is a definite integral. We've got ln of 11x dx. So our u is going to be the ln 11x. Our dv is going to be dx. We integrate that, we get x. If we take the derivative of this, it's 1 over 11x times 11. And so we just have 1 over x. All right, so if you plug those pieces in, you end up with x ln 11x minus the integral of 1, which is x, evaluated from 1 to 5. All of this is from 1 to 5. Okay, so there, that was telling that. So then what does that mean? It means you're going to plug in 5 for x here. ln 11 times 5 is 55 minus 5. So that's all substituting 5 into that. Minus, now we're going to plug in 1 for everything. It's 1. There's actually a 1 there. ln 11 minus 1. So we have 5 ln 55 minus 5 minus ln of 11 minus times minus is plus 1. If you do that on the calculator, I've shown you a calculator screen here, how to put it in. And remember, there's an ln key. Be sure you close parentheses. And it says to round to 4 places, and you would get that. Okay. Here's one done with the tabular method, number 3. You had x squared e to the 2x dx. Well, derivative column, and we did this all the way to 0. You start out with x squared, the derivative of that is 2x, the derivative of that is 2, and the derivative of 2 is 0. The other part, e to the 2x, when you take the integral, you get e to the 2x over 2. Take the integral of that, you get e to the 2x over 4 and e to the 2x over 8. And I've kind of shown you over here what's happening when I say that's what it is. All right, so we've got that product minus this product plus this. Okay, so that product minus that plus that, and you get this minus, do some canceling, x e to the 2x over 2 plus e to the 2x over 4. Again, they like to have the fractions brought out, so because that's an understood 1 and an understood 1 and an understood 1 there, that's 1/2 x squared e to the 2x minus 1/2 x e to the 2x plus 1/4 e to the 2x plus c. Okay. So number 4, you can do, you can actually do number 4 on your calculator, and I'm showing you that approach to it. Anytime you have a definite integral, you can do it on your calculator, and it's math and then choose 9. So that gives you fn int, so that's a definite integral. You put the function, we've talked about this, the function, and be sure that it is in parentheses so that you have this 6x plus 7 is in parentheses divided by e to the x in parentheses, and then you've got the whole thing covered up, so just pay attention to that. And then you have x, and then you have the lower limit and the upper limit. Okay, so when you do that and hit enter, you should get that number, round it to, and maybe it says 3 places. Let's look back. Number 4, round to 3 decimal places. So just be sure you're looking at what to do on that. Okay, the number 5, the hint on number 5, when it has the 4th root of something, you want to rewrite it as x plus 2 to the 1/4. You're going to have to do some u substitution to do that. I've shown you that to remind you over here. If we let u be x plus 2, then you've got the integral of u to the 1/4. The integral of u to the 1/4 is u to the 5/4 over 5/4. You flip the 5/4, so you have 4/5 u to the 5/4, and we put the x plus 2 back in. You end up doing that twice because you'll do the same thing here and then end up here. So you have 2 lines. This one went to 0. Multiply this times this minus this times this, and you really can't clean that up anymore. That is the answer. So quickly, I've gone over the 5 questions that you should have on your homework, and you should be able to refer to your lecture notes and the video and be able to do those.